Hello, young math Padawans. It's Mrs. Angel with your lesson for today on solving inequalities using MPOI and DPOI with negatives. So our first guiding question is, what happens when you multiply both sides of a true inequality by a negative value? And this is something that you may have learned before. There's something different that happens with inequalities when you multiply or divide by a negative. So we have two examples of inequalities here, and both of these inequalities are true. In this first one, -2 is less than 5, and in this second one, 10 is greater than or equal to -6. What we're going to do here is we're going to apply MPOI, multiplication property of inequality, with a negative value to see what happens. So let's go ahead and do that. So let's take a look at our first inequality example. Let's say I wanted to come in and multiply both sides by -3. -3. Because I'm doing it to both sides, if this were an equation, we know that it would be true because that's the definition of multiplication property of equality. But something weird happens when I simplify in an inequality. -3 times -2 is +6, and +5 times -3 is -15. Now, is 6 less than -15? No. Here's what happened. Every time you multiply by a negative, the sign is going to change. Notice how the left side of the inequality used to be negative, and now it's positive. The right side of the inequality used to be positive, and now it's negative. So why is this important? Well, anytime that your signs are going to change, you're now flipping to another side on the number line, and this symbol is no longer true. So to keep this inequality true, all we have to do is flip the sign. 6 is actually greater than -15. Let's see what happens when we do it in our second example. This time I'm going to make it even more basic. I'm going to come in and multiply both sides by -1. -1. By doing that, +10 becomes -10. Again, the sign has changed. -6 becomes +6. The sign has changed. So is -10 still greater than or equal to 6? No, we need to flip the sign to keep the statement true. Now, this is only the case when you multiply by a negative value, and we'll look at that later on in our example. Okay, so what happens when we now divide both sides of a true inequality by a negative value? Let's see. True inequality number 1, 4 is less than 12. We all agree that is true. What if I were to come in here and divide both sides by -2? My new inequality statement would be -2 is less than -6. Is that true? No, it's not, because now we went from the positive side of the number line to the negative side. This inequality is no longer true. So we have to flip the sign. -2 is greater than -6. In our last example here, -4 is greater than or equal to -12 because it's greater. But what if I came in and divided both sides by just -1? Well, my new inequality would be +4 is greater than or equal to +12. And we know that's not true. So what do? We flip the sign. Greater than or equal to becomes less than or equal to, and 4 is less than or equal to 12. So let's make a conclusion here. We've now shown that when you multiply or divide both sides of an inequality by a negative value, you must flip the sign. So now we can see what this looks like when we're actually solving some inequalities in today's example. Starting with the first one on the next page, 3x plus 5 is less than or equal to -4. So we're just going to keep in mind that if at any point we use MPOI or DPOI with negatives, we need to switch the sign. For now, let's just solve this how we normally would. So I'm going to put a line down the middle of my inequality symbol, Here we go. So on the left side, I have two terms. I'm going to go ahead and subtract 5 from both sides using my MPOI. That creates a 0 term out of the 5, and after I simplify, I'm left with 3x is less than or equal to -9. I haven't done any multiplying or dividing with negatives, so nothing has to change yet. Now that I see 3x on the left side, I'm going to divide both sides by 3 using my DPOI. Now, from now on, every time I use division or multiplication property of inequality, I'm going to write whether or not I'm doing so with a positive or a negative. Here, I'm dividing both sides by a +3, so I'm just going to write positive in parentheses. Positive mean no change. The left side of this inequality, after I simplify, is still positive. I had a positive 3x, now I have a positive x. And the right side is still negative. I started with -9, now I have -3. So since none of the signs have changed, I don't have to change anything about my symbol, and I'm pretty sure that I've correctly solved this inequality. However, there's only one way to be sure, and that's by doing the graphing and the checking. So let's go ahead and do that now. Let's see how you did. So you'll know that you're doing this right if one of your statements is true and the other is false. Is -7 less than or equal to -4? Yes, that would be our true statement, which means hopefully the other one is false. After substituting a -2, is -1 less than or equal to -4? No, that is a false statement. So that means up here in our graph, -2 is not a solution, meaning all of the points to the right of this border point are also not solutions. However, -4 is, which means all of the points on the other side are solutions, and that is where I'm going to place my solution line. That wasn't so bad. No MPOI or DPOI with negatives. Let's move on to number 2. I'm going to start, as always, by putting a line down the middle of the inequality symbol just to keep both sides separate, and that same inequality symbol will be written on that line. So on the right side, I see 2 terms. I'm going to start by making a 0 term out of the constant using my APOI. And I'm not worried about addition, nothing changes. That creates a 0 term, and I'm left with 6 is less than or equal to -2x. Now it seems I have to divide. And again, whenever I use MPOI or DPOI, I'm going to write down whether or not I'm doing so with a positive or a negative. Divide by -2. Divide by -2. So this is DPOI, and it looks like I'm doing so with a negative. So what did we learn? After I create a big 1 factor, the left side of the inequality went from a +6 to a -3. Its sign has changed. It has crossed 0. And the right side of the inequality went from a -2x to a +1x, again, crossing 0. So what do I have to do? I have to change my symbol from less than or equal to greater than or equal to. Otherwise, this statement is no longer true. So at this point, I think that I'm done. The only way to be sure is to do my graph and check. So let's go ahead and do that now. Remember, to determine if you have your solving done correctly, one of these should be true and the other false. Let's see. In the first one, is -1 less than or equal to 1? That is a true statement. In the second one, is -1 less than or equal to -3? That is a false statement, which means -2 is not a solution, and everything else on that side is also not a solution. However, -4 is a solution and deserves a solution point, along with every other value on that side. So here is my solution line. And this inequality has been solved correctly. So what did we just learn? We learned that our MPOI and our DPOI are not as simple as they seem. If we're dividing both sides of an inequality by a positive value, there is no change. However, when you're dividing by a negative, it does change. The left side has changed from negative to positive, the right from a positive to a negative. So to account for those changes, we have to change the sign. We have to change the symbol, in this case from greater than to less than. The same can be said for the multiplication property. In the first example, as long as I'm multiplying by a positive, there is no change. However, as soon as I multiply both sides by a negative, that does change the signs from positive to negative to positive, and that inequality symbol must also change. That's it for today's lesson, and I will see you next time.